I got a question for you. A question about infinite realities and alternate lives and versions of you. Are you ready? Here it is. What if you're living only one version of yourself? What if, right now, infinite versions of you are living entirely different lives? Some tragic, some amazing, all at the same time. Now, I know that sounds like a crazy sci-fi movie, but hear me out. It turns out scientists actually think this might be true. They think that there are an infinite number of universes where anything and everything that could happen is happening. It's called the multiverse, and it's one of the most controversial ideas in physics today. In this episode, I'm going to tell you what the multiverse is, how many versions of you might exist, and whether we'll ever be able to prove it's true. Let's start by answering the question, what is the multiverse? First off, let's clarify that the multiverse isn't something that's been proven to exist. There's no smoking gun, but it is a natural consequence of some of our best theories in physics, and it explains a lot of otherwise puzzling stuff about our universe. So some scientists take it pretty seriously. To talk about what the multiverse is, first we need to talk about what it isn't. Because when people hear the word multiverse, they usually think of some kind of mega-universe that combines every single universe that's ever existed. But that's not what physicists mean when they talk about the multiverse. The word multiverse means many universes. And while it seems impossible, that's literally what some of our best theories in physics say is true. For example, one theory says that every time you make a decision, the universe splits so that in one universe you go left, and in another universe you go right. That's called the many worlds interpretation of quantum mechanics, and I've made an entire video about it, which I'll link to at the end. But basically, in the many worlds interpretation, the reason you do want to remember splitting into a billion different versions of you after making a decision is that those other versions of you do want to have any memory of this particular moment. You feel like you're always in control of your decisions, but really your decision is simply a cascade of events that happened before. Your childhood, your parents' childhoods, and ultimately the Big Bang. Given enough time, everything eventually returns to chance. Like a Mexican wave rippling through a stadium, a decision cascades outward, creating ever larger ripples that spread across the entire universe. But once it's done, there's no way to tell that it ever happened. So according to the many worlds interpretation, you are every version of you that's ever made a decision, just not here in this universe. Okay, so that's one kind of multiverse. It's called the many worlds interpretation of quantum mechanics. Another kind of multiverse comes from the idea of inflation. This theory says that our universe was created when a quantum fluctuation caused a small region of space to rapidly expand. And because quantum fluctuations are random, this region expanded faster than the speed of light, faster than anything, faster than information could travel. So no one outside the bubble could know what was happening inside. And so our universe expanded forever, becoming everything that we see today. One of the predictions of this theory is that other regions of space inflated at the same time, possibly with different laws of nature. So according to the inflationary multiverse, out there somewhere, right now, there are other universes that obey the same laws of physics as ours. Only they're different. Maybe in one of them, gravity is weaker, so there are no stars or planets or black holes. Or maybe there, as a big star in the middle of our solar system that makes Earth a molten blob of rock. Or maybe there's no life at all. Okay, so those are two kinds of multiverse, the many worlds interpretation and inflation. But there are two more that come from the fields of string theory and mathematical cosmology. String theory is a framework that attempts to combine all the forces of nature into one. The basic idea is that everything in the universe is made of tiny vibrating strings. The different vibrations correspond to the different particles we see. But to do this, string theory requires 9 dimensions of space. Now we only experience 3, so the other 6 have to be curled up really small. But according to string theory, these extra dimensions can vibrate too. And it turns out that there are an infinite number of ways they can do so. So that means that in addition to the universe that we live in, there are 10 to the 500 different possible universes, each with different physical constants. Finally, there's the mathematical multiverse. This is the idea that every possible mathematical structure exists as a universe. So in some universes, pi is 3. In others, it's 4. In some universes, time moves backwards. In others, it stands still. In some, there are infinitely many dimensions. In others, only one. This is the multiverse of mathematical possibilities. Okay, so that's what the multiverse is, an infinite number of universes that are impossible for us to observe directly. If you're keeping track, that's for different multiverses. So which ones are we in? Well, almost certainly we're in the many worlds interpretation, and we're also in the inflationary multiverse, but we don't know about the others. Maybe we're in none of them. Okay, so that raises the question, what's different in these other universes? Well, everything and nothing. Nothing in the sense that these other universes have the same fundamental laws that we do, but everything in the sense that since the laws have different constants, they play out in different ways. In some universes, the constants are such that stars explode earlier, so civilizations never get a chance to develop. In others, they develop further, and some become multiplanetary or even multi-universal. You could be in a universe where humans never developed. You could be in a universe where we did, and you became a billionaire. You could be in a universe where you died young or never were born at all. In some universes, you might be watching this video on a phone made of bone. In others, you might be watching this video on a screen made of flesh. Okay, so there are an infinite number of versions of you in an infinite number of universes. But is there any way we'll ever know? Well, as it stands right now, the only way we could ever know is if some version of you found a way to travel between universes and brought back evidence. Otherwise, the only way we can ever know is by finding indirect evidence. And this is actually something that scientists are doing. For example, there's some hints in the cosmic microwave background. The cosmic microwave background is radiation left over from the Big Bang. It should be evenly distributed in all directions, but some measurements have shown that it's slightly hotter in one direction and colder in another. And while this could be explained by some kind of new physics, it could also be explained by another universe leaking its heat into ours. There's also hints in quantum randomness. Quantum mechanics is fundamentally random, and that randomness appears in some places in our universe, like in the radiation that hits Earth from the sun. But it shouldn't appear in others, like in the orbits of planets around the sun. And it turns out that observations of planetary orbits are slightly more random than they should be. Again, this could be explained by new physics, but it could also be explained by mini-worlds. Specifically, the idea that the randomness of quantum mechanics gets hidden or decarred when systems get large. So in this picture, it's not that planets follow random paths, it's that they follow many random paths that interfere and cancel each other out. Finally, there's the fine-tuning of constants. The amazing thing about our universe is that the constants that appear in the laws of physics seem to be finely tuned for life. For example, if gravity was much stronger, stars would collapse before they had a chance to form. If electromagnetism was much weaker, atoms wouldn't exist. And if the strong nuclear force was much stronger, protons and neutrons wouldn't hold together. These are just a few examples of the constants that seem finely tuned for life. It's a coincidence that we live in a universe that allows life to flourish, but that doesn't explain why. One possible explanation is that there are other universes that do not have the same constants, and those universes either do until our life or life co-until reproduce or it dies out quickly. Only universes with the right constants survive. That's called the anthropic principle, and it's highly controversial, but some scientists take it seriously. So that's the multiverse. Is there any way we'll ever prove it exists? Probably not. The problem is that by definition, we can't observe other universes because they're outside our observable reality. But that doesn't mean we won't keep looking. After all, if there's another universe out there with a version of you that found a way to travel between universes, then maybe that version of you has already proven the multiverse exists, but just not you in this universe. So I got one final question for you. Which version of you is going to figure out how to travel between universes first? Let me know in the comments. If you enjoyed this video, you might want to check out my quantum physics playlist, where I talk about the greatest mysteries of the universe, like Schrödinger, SCAT, the double-slit experiment, and what the heck is the Higgs boson. I'll put the link right here. And finally, here's a special message from my sponsor, Brilliant. I've said it before, and I'll say it again. Math is the language of the universe. And if you want to understand the world around you, you have to understand math. Unfortunately, most of us don't learn very much math after high school. But the good news is that you do need to be a genius or spend years in school to learn some of the most important ideas in math and science. Thanks for watching.